Welcome friends. In this video, I will discuss a problem which was asked in West Bengal Joint Entrance Examination 2023. Here we use the question booklet code C and question number 2. What is the question? Suppose f r to r be given by fx equal to 1 if x equal to 1 and e to the power x to the power 10 minus 1 plus x minus 1 whole square sin 1 upon x minus 1 if x not equal to 1. Then option A, f dash 1 does not exist. Option B, f dash 1 exists and is 0. Option C, f dash 1 exists and is 9. Option D, f dash 1 exists and is 10. Now we use the definition of derivative of a function at a point. What is f dash 1? By definition f1 equal to 1 and f dash 1 is equal to limit x tends to 1 fx minus f of 1 by x minus 1. Now since x tends to 1 means x not equal to 1. So when x not equal to 1, we use the definition of fx, that is fx when x not equal to 1, fx equal to e to the power x to the power 10 minus 1 plus x minus 1 whole square sin 1 upon x minus 1. So we have limit x tends to 1 e to the power x to the power 10 minus 1 plus x minus 1 whole square sin 1 upon x minus 1 upon minus 1 upon x minus 1. Now using a plus b upon c is equal to a upon c plus b upon c, we get limit x tends to 1 e to the power x to the power 10 minus 1 upon x minus 1 plus x minus 1 upon whole square x minus 1 whole square times sin 1 upon x minus 1 by x minus 1. And since x minus 1 not equal to 0, therefore we cancel x minus 1 from denominator and numerator, and we will obtain x minus 1 into sin 1 upon x minus 1. If we let e to the power x to the power 10 minus 1 upon x minus 1 limit as x tends to 1 exist, and similarly limit x tends to 1 x minus 1 sin 1 upon x minus 1, both these limit exist, then the whole limit exists. So we let gx equal to e to the power x to the power 10 minus 1 for all x belongs to R, the set of real numbers. Therefore, then g1 equal to e to the power x to the power 10 minus 1 equal to x to the power 1 minus 1 equal to x to the power 0, which is equal to 1. And also we also let hx equal to x minus 1 times sine 1 upon x minus 1 for all x belongs to real number with x not equal to 1. So what is dx? Dx equal to e to the power x to the power 10 minus 1. Therefore, limit x tends to 1, gx minus g1, since g1 equal to 1, upon x minus 1, plus, and since hx equal to x minus 1 times sine 1 upon x minus 1, therefore, plus, limit x tends to 1 hx. Now we have to calculate, but by definition, limit x tends to 1, gx minus g1 upon x minus 1 is equal to g dash x, plus limit x tends to 1, hx. Now we have to calculate g dash 1. G dash is equal to d dx of gx, which is equal to e to the power x to the power 10 minus 1, which is equal to d dx e to the power u, where we let u equal to e to the power x to the power 10 minus 1. So using chain rule, we have d du of e to the power u times du dx. But d du of e to the power u equal to e to the power u. So we have e to the power u times d dx of x to the power 10 minus 1. But d dx of x to the power 10 equal to 10 times x to the power 9 times e to the power u, but e to the power u is nothing but e to the power x to the power 10 minus 1. So we get g prime x is equal to 10 x to the power 9 times e to the power x to the power 10 minus 1. Consequently, g prime of 1 is equal to 10 times 1 to the power 9 times e to the power 1 to the power 10 minus 1, which is equal to 10 times 1 to the power 9 is equal to 1 times 1 to the power 10 minus 1 equal to 1 minus 1 is equal to e to the power 0. So, this is equal to 10 into 1 into 1, which is equal to 10. So, we have g prime of 1 is equal to 10. Therefore, we have putting the value of g prime 1, which is as earlier we obtained g prime of 1 equal to 10. So, we have f prime of 1 is equal to 10 plus limit x tends to 1 hx. Now we have to calculate limit x tends to 1 h of x. What is the definition? Hx equal to x minus 1 times sine 1 upon x minus 1 for all x belongs to R with x not equal to 1. So, modulus of hx is equal to modulus of x minus 1 times sine 1 upon x minus 1, which is equal to x minus 1 modulus of x minus 1 times modulus of sine 1 upon x minus 1. Here we use the formula modulus of AB is equal to modulus of A into modulus of B. Since sine 1 upon x minus 1 less equal to 1, therefore we obtain this hx less equal to x minus 1. Consequently, we have negative modulus of x minus 1 less equal to hx less equal to modulus of x minus 1 for all x belongs to R with x not equal to 1. We see that modulus of x minus 1 goes to 0 when x tends to 1. Similarly, minus modulus of x minus 1 goes to 0 when x goes to 1. So, by Sandwich theorem, we obtain hx goes to 0. Therefore, limit x tends to 1, h of x is equal to 0. Now, putting the value of limit x tends to 1 hx as 0, we obtain f prime of 1 is equal to 10. Consequently, f prime of 1 exists and is 10, that is option D is correct. Thank you for watching this video. Please subscribe our channel to view more such videos in future.